Chapter 6, Lesson 3 of Advanced Algebra. We're going to do some examples of dividing polynomials using long division. And then we'll also discuss whether these linear factors or these divisors are factors of the polynomial or not. Okay, so we're going to start off with number 1 here. I have the answer already here so we can kind of see where we're going. So just like any division problem that's written like this, we'll need to write it in the long division form. So we're going to do p plus 1, and we're going to divide that into 5p cubed plus 2p squared minus 8p plus 1. Now, like we talked about, there is the caveat. We need to make sure that every power is represented, so I always double check that at the beginning. So I have a 3, I have a 2, I have a 1, and then I have a 0. So every power is represented, so I can go ahead and do my division. So I take a look at just the letter p, and I ask myself, how many times does the letter p go into 5p cubed? So I'm going to have to multiply p times 5p squared, and if I multiply that together, I'm going to get 5p cubed. And then I multiply the 5p squared times the 1, so that's plus 5p squared. Now be careful here, because here's where we have to change the sign of both of these, okay, and then add those. So 5p cubed minus 5p cubed is 0, and then 2p squared minus 5p squared is negative 3p squared, and then I bring down the next value. And now I go back to the letter p into negative 3p squared. So I'm going to need to multiply by negative 3p. Negative 3p times p is negative 3p squared. And then negative 3p times a positive 1 is negative 3p. Now again, we need to change the sign of both and then add. So this is 0, and so this is going to give me negative 5p, and then I'm going to bring down the 1. Okay, now again, I go back to the letter p and I go into negative 5p, it'd be negative 5, because negative 5 times p is negative 5p, and then negative 5 times 1 is negative 5. Now again, I need to change the sign of both and then add, so that's 0, and then this is 6. There's nothing else to bring down, so I have a remainder of 6. So it's a positive 6, so it's plus, and then I take my remainder and I put it over the divisor, p plus 1, so this would be my answer. Now what does this tell me about this divisor, p plus 1? It tells me that it is not a factor of this cubic polynomial because the remainder is not 0. Okay, so that's long division, and so let's go ahead and do the next problem. In this problem, I'm going to take m minus 5, and I'm going to divide that into m cubed minus 3m squared minus 9m plus 2. And again, I want to make sure I have all the powers, so I start with a 3, 2, 1, and 0. So everything's represented, so I go ahead and do my division. So m goes into m cubed, m squared times, because m squared times m will give me m cubed. And then the m squared times the negative 5 is negative 5m squared. And be careful, we have to change the sign of both and then add. So this is always going to add to 0, and this is going to be 2m squared, and then I bring down the next number, and then I repeat the process. M into 2m squared is a positive 2m. 2m times m is 2m squared, and then 2m times negative 5 is negative 10m. Change the sign of both. That's 0. This is 1m, and then I bring down the 2. M goes into m one time. 1 times m is 1m, and then 1 times negative 5 is negative 5. Change the sign of both and add. So there's nothing else to bring down, so this is my remainder. So that's a positive 7, and I put it over my divisor of m minus 5. So this is my answer. So again, this tells me that m minus 5 is not a factor of this polynomial. And again, that's very important. That's what we're doing division for, because remember, that's what division tells me, whether this is going to be a factor of this or not. Division is the test. All right, so let's do a couple more. I'll do one more kind of on the easy part, and then we'll skip up and maybe take one on that's a little bit more difficult. So we're going to take n plus 5 here, and we're going to divide it into n cubed plus 8n squared, plus 13n minus 6. So a 3, 2, 1, 0. I have all my powers represented, so I'm okay. N goes into n cubed, n squared, because n squared times n is n cubed. And then that times the 5 is 5n squared. That should be an n right there, shouldn't it? Okay. Change the sign of both, remember? All right, and that's 0, and then 8 minus 5 is 3n squared. And I bring down the next one. N goes into 3n squared 3n times, because 3n times n is 3n squared. 3n times 5 is 15n. Remember to change the sign of both. Okay, so that's 0. And 13 minus 15 is negative 2n. Bring down the 6. N goes into negative 2n, negative 2 times. Negative 2 times n is negative 2n. Negative 2 times positive 5 is negative 10. Change the sign of both and add 4. So there's nothing else to bring down, so this is my remainder. It's a positive 4 as a remainder over my divisor n plus 5. So this would be my answer. And again, that tells me that n plus 5 is not a factor of this polynomial because my remainder is not 0. All right? Let's go up and see what the more difficult ones have in store for us. All right, let's take a look at this one. And we have 4m plus 8. Oh, okay, that's a little bit more difficult. 4m plus 8. And I'm going to divide that into 4m to the 5th plus 4m to the 4th plus 4m cubed plus 4m squared minus 8m plus 67. Ooh, that's a rather long problem we have to do. Okay, everything's the same. It's just a little bit more difficult from a number standpoint, maybe. So 4m into 4m to the 5th, well, that's going to be m to the 4th. Notice this is always one less than this. Something to note for further reference. This is always one less than this. All right, so m to the 4th times this is 4m to the 5th. And then this times this is going to be 8m to the 4th. Now, we're going to change the sign of both. Remember that? So that's 0. And 4 minus 8 is negative 4m to the 4th. And then I'm going to bring down my next one. Now, 4m into negative 4m to the 4th is negative 4m cubed. That's not right. I don't need a 4. I already have a 4m. So that's going to be just a negative m cubed. Negative m cubed times 4m is negative 4m to the 4th. Negative m cubed times 8 is a negative 8m cubed. So then remember to change the sign of both and add. So that's 0, and this is 12m cubed. And then I'm going to bring down a 4m squared. All right, so 4m into 12m cubed is going to be a positive 3m squared. The 3 times the 4 will give me the 12. The m squared times the m is m cubed. And then the 3 times the 8 is 24. And then we have m squared. All right? So remember to change the sign of both and then add. So that's 0. And this is going to be negative 20m squared then. And we're going to bring down negative 8m. Now, 4 into negative 20 is negative 5, and then I'm going to need m. So negative 5 times 4 is negative 20, and then the m times the m is m squared. The negative 5 times the 8 is negative 40, and that's going to be m. Change the sign of both and add, so that's 0. And this is going to be 32m plus 67, bringing down the last number. And now 4 into 32 is going to be 8. So the 8 times the 4 is 32, and then the m, and then the 8 times the 8 is 64. We're going to change the sign of both and add, so that's going to be 3. So there's nothing else to bring down, so this is my remainder. So my remainder is a positive 3 over my divisor of 4m plus 8. So this is my answer using long division. Again, that tells me that 4m plus 8 is not a factor of this polynomial because it does not come out even. All right, so you can see that's quite a lot of work. You'll be excited when we learn synthetic division because that's going to help us shorten this up a bit. All right, let's do two more of these more difficult ones and see what it has to throw at us. So let's take a look at number 7 here. So we have 7x minus 6, and we're going to divide that into 14x to the 5th minus 12x to the 4th. Now, here's that caveat. Notice there is no x cubed, but I need to put a placeholder in for x cubed. There also is no x squared, so I need to put in an x squared. Now I do have an x, 35x, and then I do have a constant negative 22. So this is one of those cases where we have to remember to put these placeholders in to make sure that we have what we need in order to make our division work properly. All right, so then we just go ahead and do everything else the same. So 7 goes into 14 2 times, and then x into x to the 5th is going to be x to the 4th. Again, notice that that is 1 less than what we began with. Important to know when we get to synthetic division. So then we're going to multiply. So the 2 times the 7 is 14. X to the 4th times x is x to the 5th. And then the 2 times the negative 6 is the negative 12, and then that's x to the 4th. So I need to change the sign of both and add. So this is 0, and this is also 0. So I have 0x to the 4th, and I'm going to bring down 0x cubed. Now 7 goes into 0 0 times. Okay, so we'll go ahead and put it up here, and then we'll take it out at the end. So this would be 0x cubed. All right, so that's going to be 0x to the 4th plus 0x cubed. Change the sign, that's going to be 0x cubed. We're going to bring down 0x squared. So now we're going to divide 7x into 0x cubed. Well, again, that's going to be 0 and then x squared, because x squared times x is going to give me x cubed. So 0x cubed and 0x squared is going to leave me 0x squared, and then I'm going to bring down my 35x. Now, 0 into 0x squared is still 0 here. 0 and then x, because x times x is going to give me x squared, so that's 0x squared plus 0x. Change the sign and add, so this is going to be 35x, and then I bring down my 22. Now, 7 goes into 35 5 times, and then we have x. So 5 times 7 is 35. And then we have x, and then 5 times negative 6 is negative 30. So we change the sign of both and add, so that's an 8. There's nothing else to bring down, so 8 is my remainder. So now I don't need to write these down in my final answer because those are all 0x. So my final answer would be 24x to the 4th plus my 5, and then plus my remainder of 8 over my divisors, 7x minus 6. So this would be the answer. And again, what does that tell me? That tells me that this is not a factor of this because the remainder that I get is not 0. Okay? We'll do one more, hopefully. Well, tell you what, we'll do 2 more, and then you can watch as many as you need to watch. Let's do this one right over here, number 8. So again, we're going to do r plus 3, and we're going to divide it into r to the 5th plus 6r to the 4th plus 9r cubed. Now again, I don't have an x squared, so I need a placeholder. And I don't have an x, well actually it's an r, excuse me. Let me go back and make that right. I don't have an r squared, so I need that as a placeholder. And I don't have an r, so I need a placeholder. And then I have minus 8. So now that I have all my placeholders in place, I can go ahead and divide. So r goes into r to the 5th, r to the 4th. Again, notice this is 1 less than this one here. Again, it's something, a connection we'll want to make when we're doing the next. So then we multiply those as 3r to the 4th. Remember to change the sign of both and add. So that's 0. 6 minus 3 is 3r to the 4th. We'll bring down the next number, 9r cubed. r goes into 3r to the fourth, 3r cubed. 3 times 1 is 3, r cubed times r is r to the fourth, and then the 3 times 3 here is 9r cubed. Now again, we'll change the sign of both and then add them. So this is 0r cubed, and we're going to bring down a 0r squared. Now, we could go through this whole process. I know this is going to be a 0r squared, and then I'm going to bring down 0r. And I know this is going to be 0r, so I'm going to bring down 0r, and then it's just going to leave me minus 8. So this is going to be my remainder. So notice this is a negative this time, so my quotient is r to the fourth plus 3r cubed minus my 8, it's negative 8, over my divisor r plus 3. So this would be my answer. Now again, notice, what does that tell me? It tells me that r plus 3 is not a factor of this quintic polynomial. Okay, we'll do one more and then we'll wrap this division stuff up. Okay, so let's take a look at this last example. It has a couple things going on actually. So we're going to take 5n minus 5 and we're going to divide it into, now there's something interesting going on here. We'll see if we can't catch it. 5n to the fifth minus 5n to the fourth. Now my cubic should come next, but notice what's next in here. This divisor, dividend, is not in standard form. And it's something we didn't talk about, but something we should always remember, to put it in standard form. I talked about at the beginning when we're talking about standard form of polynomials. Before we do any kind of classifying or multiplying or dividing or anything, we should always make sure that the polynomials are in standard form. So I actually need to put this negative 5n cubed in next, and then I have the 10n squared, and then I have the negative 10n. So this is in standard form now, and again, if I'm watching to make sure that I have placeholders, I would catch that as well, because I need to go 5, 4, 3, 2, 1, and then a 0 out here if I wanted to. So be sure that you make, be careful to make sure that these are in standard form, or at least you have the placeholders in order. So once I have that, we can go ahead and do our division. So we're going to divide 5n into 5n to the fifth, so this is going to be n to the fourth. Again, you'll notice that this is 1 less than this. So this is 5n to the fifth minus then 5n to the fourth. So I'm going to change the sign of both and then add. So this is going to give me 0n to the fourth. Now we've been carrying these out before we've been carrying these out and just doing 5 into 0, but we can actually, because this is 0n to the fourth, that's not going to be anything. I can just go ahead and bring down the next number and begin my division from there. So actually I can bring down the next 2. So 5 into negative 5n cubed is going to be negative n squared. So that's going to be negative 5n cubed, and then this negative times the negative is going to be a positive 5n squared. So we're going to change the sign of both as we've been doing, and then add. So this is going to be 10 minus 5, so that's going to be 5n squared, and we can bring down the negative 10n. So 5n into 5n squared is going to be n, so that's going to be 5n squared, and then I'm going to have negative 5n. We'll change the sign of both, and then add. And then we can multiply this by negative 1, because negative 1 times this is negative 5n, and then I have a plus 5, and then we're going to change the sign of both and then add. Now, you'll notice that my remainder then is negative 5 over 5n minus 5. Now you'll notice that doesn't match their answer. And what they've done is this can actually be simplified. Because we have a common factor of 5 down here, we can take that out, factor that out, and then because I have multiplication going on, these 5's reduce, leaving me 1. So that's how they get their answer. N to the fourth minus n squared plus n minus 1 with a remainder of a negative 1 over n minus 1. Okay, so what does that tell me about 5n minus 5? It tells me that 5n minus 5 is not a factor of this polynomial. Okay, so again, the division is the test for making sure or determining if something is a factor of another number, and this is doing long division with polynomials.